Hey guys, this is Mr. Gucci with your 10.3 notes video, the percent yield notes. All right, so let's talk about what percent yield is. All right, now, percent yield is a measure of how efficiently the products of a chemical reaction are collected. And let me tell you what I mean using an example. So let's say you have yourself, I don't know, a bag of, say, Sour Patch Kids, all right? Let's say you have a bag of Sour Patch Kids, and that bag of Sour Patch Kids says that it contains exactly 100 grams of Sour Patch Kids. Let's assume that that's true. All right. You got a bag here, 100 grams, 100.0 grams of Sour Patch Kids. All right. Now, let's say you sit down, you eat the whole dang thing. Okay. You eat it all. All right. All of it is eaten, or so you say. Right. But I ask you this, if you eat the whole bag of Sour Patch Kids, did you eat exactly 100 grams? Did you eat a little less than 100 grams? Did you eat a little more than 100 grams? How much Sour Patch Kid did you actually eat? I want you to pause this video and think about it for a little bit. If there is a bag of 100 grams of Sour Patch Kids and you eat the entire bag, did you eat exactly 100 grams, less than 100 grams, or more than 100 grams? The answer, guys, is you ate less than 100 grams. And the reason is, if you've ever eaten Sour Patch Kids, you know that Sour Patch Kids are covered with that Sour Patch dust, all right? And as you're eating, some of that dust falls off. Maybe it sticks to your fingers. Maybe it falls on your desk. It's usually, there's usually a lot of it left in the bottom of the bag, and you don't eat it because it's just pure sour powder, unless you're a crazy person, all right? So the reason why you will never eat the full 100 grams of Sour Patch Kids is because a little bit is lost along the way. All right. A little bit is lost along the way. Always, no matter how careful you are, if you just lose just one little grain of that sour powder, then you have lost a little bit along the way. Okay. It's the exact same in chemistry. All right. So, for example, let's take this example from the notes. All right. How many liters of oxygen gas are produced if 45 grams of potassium chlorate decompose? All right. Well, you balance the equation, you convert the starting amount into moles, you go from moles of A into moles of B, all right, you convert that final amount of moles of oxygen into liters and you get an answer. You will get 12.3 liters of O2. If you decompose 45.0 grams of potassium chlorate, you should get 12.3 liters of oxygen gas. Or will you? This 12.3 liters represents the maximum amount of oxygen gas you will be able to capture. But just like you could not eat all the Sour Patch Kids because you lost a little bit along the way, there's no way you're going to collect exactly 12.3 liters of O2. Maybe you lose a little bit of potassium chlorate. Maybe some of the oxygen gas leaks out and you don't get a chance to collect it. In chemistry, you never get 100% of the stuff that you set out to capture. All right? And the percentage that you are able to get is the percent yield. Percent yield is what percent of your product you were actually able to collect. And the formula for percent yield is quite simple. Percent yield is just the amount of substance that you were actually able to collect from an actual chemical reaction divided by what amount you predicted you should have been able to get. All right? The top of this fraction right here, you get that from actually running the chemical reaction and seeing how much stuff you collect. The bottom of this fraction right here, you get that from calculating using stoichiometry. Okay, that 12.3 liters O2, that is the theoretical maximum amount of oxygen that you should get if you react every single tiny bit of potassium chlorate. Okay, but you're not going to. Some will be lost along the way. So the percent yield is the amount you produced divided by the amount that you predicted. And it's a percent, so you got to multiply it by 100%, all right, to turn that into a percent, okay? Now, this is not a violation of conservation of mass and matter, okay? Like I said, you got 100-gram bag of Sour Patch Kids. Oh, but you don't eat 100 grams. Maybe you eat 99.9 grams. Well, that like 0.1 gram it didn't just disappear. It didn't cease to exist, all right? It's not a violation of conservation of matter. It just got lost, all right? It maybe fell on the floor, fell on your desk, maybe got stuck in your beard if you have a beard like I do, okay? I don't know, okay? So the reason why you never have 100% yield, why you never get 100% of what you predicted is because maybe the reaction doesn't complete all the way. All right, that's like maybe you didn't eat all of the bag. You left like a few Sour Patch Kids at the bottom. All right, your tongue started to hurt. All right, or maybe there was some residue left behind. All right, this would be like you lose some of your little Sour Patch dust as you go along. All right, maybe you spill the Sour Patch Kids on the floor, and like I don't know, you don't want to eat it off the floor, so you've lost some. All right, or maybe it's impure. Maybe inside your bag of Sour Patch Kids, there's like a rock. And so you're obviously not going to eat that rock, and so you're not going to eat the full 100-gram bag. All right, there's plenty of reasons why you should have less than 100% yield. And these are all just normal things that happen. Even in the most precise, high-tech chemistry lab, you're going to lose a little bit. You're not, even if you lose like a single molecule, you've lost a little bit. All right. Now, percent yield over 100% is always bad. All right. In fact, I would say it's worse than having below 100% yield. Like, let's say you set out to eat 100 gram bag of Sour Patch Kids, and when you're done eating, you realize you've eaten 110 grams. Well, guess what? That was probably not Sour Patch Kid. All right. I don't know. Maybe there was a bug in there. Maybe you ate a bug. Okay. If you get more substance than you predicted as the theoretical maximum, that usually means that there's something contaminating your results. All right. Maybe something else slipped in, or maybe after the chemical reaction, maybe the Sour Patch Kids were open and they started growing mold on them. And so as the mold grows on it, it gets heavier and heavier with more and more mold. And so, yeah, maybe you ate some mold instead, okay? So ideally, when you're doing a chemical reaction, you're looking for a percent yield that's as close to 100, but not going over, right? It's like the Price is Right rules. You want to get as close to the most accurate answer without going over. Because if you go over, that means there's something else in your product, a contaminant that now you got to try and get out, okay? Now, percent yield problems are real simple. I'm going to run a few of them as a sample on your homework. But here's one example, right? So you predict that a reaction will produce let's see, get a little pen, right? You predict that a reaction is going to produce 132.4 grams of H2O. Okay, this is the theoretical. Okay, this is what you predict with math. Okay, this is what you predict with math. All right. On the other hand, when you run the experiment, what you are able to collect is that many grams of H2O. This is the actual amount. This is what you get from running the experiment. Okay, so the percent yield is just the actual amount that you get divided by what you predicted. So 114, that's your actual amount, divided by what you predicted. And we see in this chemical reaction, we got a percent yield of 86.3%. That's 114.3 divided by 132.4. That's 86.3%. Now, we lost some along the way here. If my math is correct, we lost 13.7%. Where did it go? I don't know. Maybe it fell down the drain. It's H2O we're talking about, so maybe it evaporated. I don't know. But basically, you were only able to get 86.3% of the water predicted. All right, and that's okay. All right, that's not the worst thing. All right. So, anyways, this is the end of this video. The next video I'm going to upload for this is going to be a homework help video.